Pick up something metal in your house, a cast iron pan, an old wrench, and feel the weight of it. There was a time when the inside of your washing machine was built like that, out of heavy metal. Cast gears, steel shafts, a porcelain-coated steel tub, parts that felt like they could survive anything, because they nearly could. Today, much of that core has been quietly replaced. Some of it is plastic now, and one hidden structural part in particular, the piece that actually holds your spinning drum, has been swapped for a light metal that corrodes and cracks years before the motor ever would, sometimes in as little as 7 years, and it happens even on the most expensive machines money can buy. Tonight I am going to show you that part, and the others like it, and why the change from heavy metal to cheap material is the quiet reason so many machines die young. Let me introduce you to the single most important part you have never heard of. It is called the spider. In a front-loading washer, your clothes tumble inside a stainless steel drum, and that drum has to be connected to the drive shaft that spins it, the shaft that rides in the bearing. The part that makes that connection is a casting shaped like a 3-armed star, bolted to the back of the drum, and that is the spider. It carries the entire load of the drum, the water, and your clothes. Every rotation, at every speed. It is one of the hardest working structural parts in the whole machine. And on most modern washers, to save weight and money, that spider is made of a cast aluminum alloy. Now here is the problem with that choice, and it is pure chemistry. Aluminum is light and it is cheap, but it does not like living where the spider has to live, which is in a constant bath of hot water and detergent. Detergent is harsh, and most people use far too much of it, and that chemistry slowly eats at the aluminum. The spider corrodes. Over years, that corrosion eats into the arms of the star, they grow weak and pitted, and eventually one of them cracks under the load of a spin. When that happens, the drum starts to wobble and hammer, and the machine is finished, because that spider is bonded to the drum and sold only as a huge assembly, if it is sold at all. A structural part, the literal backbone of the machine, quietly dissolving from the inside, because it was made of the wrong metal to save a few dollars and a few pounds. And there is an extra twist of chemistry that makes it worse, one that any mechanic would recognize on sight. The drum bolted to that spider is stainless steel, and the spider itself is aluminum, two different metals touching each other in water. When you put two dissimilar metals together in a wet, soapy environment, you create something very close to a weak battery, and one of the two metals is driven to corrode faster because of it. It is called galvanic corrosion, and it is the same reason boat owners obsess over the metals below their waterline. In your washer, the aluminum spider is the metal that loses that battle, sacrificed a little more with every warm, soapy load. So the spider is not merely sitting in a harsh bath. It is wired by its own choice of materials to eat itself alive. If you have ever had a washer start to shake itself apart on the spin cycle and had no idea why, then subscribe to Still Running, because finding the hidden part that actually failed and the reason it was built to fail is the whole purpose of this channel. Now let me widen the lens, because the spider is just the most dramatic example of a much bigger change. Look around the rest of a modern machine, and you will find the same story told a dozen times over. The outer tub, the big stationary drum that holds the water, used to be porcelain-coated steel, heavy and permanent. Now it is very often plastic. The pump housing, once metal, is now plastic. The gears and couplers that used to be cut metal are now molded plastic or nylon. The body panels are thinner gauge steel than they once were. Everywhere you look, a part that used to be robust metal has been replaced by plastic or by a lighter, cheaper alloy. And each of those substitutions does the same two things. It saves the manufacturer money and shipping weight, and it introduces a part that cracks, warps, or corrodes years before the heavy metal version ever would have. And it is worth understanding why weight, of all things, became the enemy. A washing machine is heavy, and it has to be shipped from a factory that may be an ocean away, to a warehouse, to a store, and finally to your house. Every single pound of metal in that machine costs money to move at every stop along that journey, on top of the cost of the metal itself. So a lighter machine is cheaper twice over, cheaper to build and cheaper to ship, and across millions of units, those savings are enormous. Plastic and thin aluminum are simply how you take the weight out. The catch, of course, is that the weight was never just weight. The weight was the durability. When they ship the pounds out of the machine, they ship the lifespan out right along with them. Here is the rehook, the thing to hold on to. This is not about one bad part or one bad brand. It is a philosophy of materials applied across the whole machine. The old machines were overbuilt out of metal because metal was how you made something last, and everyone understood that. The new machines are built out of the lightest, cheapest material that will survive the warranty, because that is how you hit a price and a shipping cost. Nobody forgot how to cast a steel part. They simply decided, part by part, that lasting was not worth the weight or the money. And your washing machine is the sum of 100 of those small decisions. And I want to kill one comforting idea right now, because it will cost you money if you believe it. The idea that you can just buy your way out of this by going premium. It is not true, and the Spyder proves it. Even the most respected high-end machines, the expensive European brands people buy specifically because they are supposed to last, use these same corroding aluminum Spyders. Owners of premium machines have reported the Spyder failing and totaling the machine in around 7 years, the same as far cheaper ones. Paying more got them a nicer door, a quieter motor, and better electronics. But the same fundamental structural weakness was hiding in the back of the drum the whole time. The cheap material problem is not a budget brand problem. It is an industry-wide problem, and price is no shield against it. And when that Spyder finally fails, the repair is its own cruel joke, for the exact reason we have run into before. The Spyder is bonded and bolted to the stainless drum as a single unit, so you cannot just buy a fresh Spyder for a few dollars and swap it in. You have to buy the entire drum and Spyder assembly, which can run several $100s, plus the hours of labor to nearly dismantle the machine to reach it. So a corroded structural bracket, a part that is essentially a bent piece of cast aluminum, ends up totaling a machine that may have cost $1,000 or more. The cheap material did not just fail early, it was mounted in a way that made its failure fatal to the whole machine. You can hear the instinct for this in what durability-minded people say, even about engines. On one thread about why old engines last, the most upvoted mechanical opinion was blunt. Cast iron is the best, they said. Aluminum is just not solid enough. That is a shade tree wisdom that turns out to be exactly right about your washing machine too. The people who grew up around real metal can feel the difference in their hands. The heft that meant a thing was built to endure, and they are not wrong to mourn its replacement by something that flexes, cracks, and corrodes. So what do you actually do with this? First, and this is the single most useful tip in this whole video, use far less detergent than you think you need, and use the high-efficiency kind. Excess detergent is one of the main things that accelerates the corrosion of that aluminum Spyder and gums up the rest of the machine, so cutting way back is the cheapest, easiest thing you can do to make the metal you do have last longer. Most people pour in 2 or 3 times what they actually need, so try cutting your dose in half, and then in half again, and watch how your clothes come out every bit as clean. Second, when you shop, ask about materials directly. Is the tub stainless or plastic? What is the Spyder made of? Most salesmen will not know, and that itself tells you how far down the priority list durable materials have fallen. Third, respect the old heavy machines for exactly what they are, tanks built out of real metal, and think hard before trading that heft for something that weighs half as much because half the metal is gone. I am not telling you that all plastic is evil, or that aluminum has no place in a machine, because that would be simple-minded, and you deserve better. Plastic and aluminum are fine materials used in the right places. I am telling you that they have been pushed into the wrong places, into the load-bearing, hard-working structural heart of the machine, where heavy metal used to live, and that they were pushed there to save cost and weight, not to serve you. The Spyder that corrodes, the tub that cracks, the gear that strips, these are not accidents. They are the predictable result of choosing the cheaper material for a job that always needed the stronger one. Once you can feel that difference, in your hands and in your head, you will never look at the weight of a machine the same way again. If you want to keep learning exactly which corners got cut inside the machines in your home, and how to find the few that still have the metal in them, then subscribe to Still Running. Because the heavy old machine in the basement is not just nostalgia, it is a standard of materials we abandoned, sitting right there, still spinning, proving every day that we knew how to build them to last, and simply chose to stop.